Hello everyone. In the last session, we have discussed about 4G and 5G technology. In this session, we are going to look at Wi-Fi as well as LPWAN. So first, let's start with Wi-Fi. So we have already seen Wi-Fi, right? Similarly, we have another technology called Wi-Fi, which means light fidelity. Okay, it was proposed by the German physicist named Harald Haas. So he is called as father of Wi-Fi, Harald Haas. So as I already told you, it is very similar to Wi-Fi technology, and Wi-Fi is going to be the future of wireless communication technologies. So a lot of research is being conducted on Wi-Fi. So we will see so many improvements in the near future. Okay, so in Wi-Fi, the data transmission is done using light. Okay, so what happens basically is the light from the bulb or from the light source will be flickering so fast that the human eye cannot distinguish, and the data will be transmitted in the form of light flashes or light flickering. Okay, right, and Wi-Fi speed can be 100 times faster than what is supported by Wi-Fi. So it is light speed. Okay, alright, so let's see how Wi-Fi works. So here let's consider this as sender, and here this is receiver. Okay, so the data from the sender will be going to this LED lamp or LED bulb. Okay, so based on the signal, the modulated signal, the light will be flickering. Okay, so this LED bulb or LED lamp will be flickering the light, and we don't notice any difference in the light. Okay, it is the flickering cannot be distinguished by the human eye. Okay, so on the receiving side there will be something called photo detector, which will receive this light, and it will send that received light to amplifier, which will amplify the light signal, and then finally send it to the receiver device. Okay, so this is how Wi-Fi basically works. The two main components in Wi-Fi technology is are one is LED lamp and another one is photo detector. Okay, right. So the Wi-Fi system will contain two main entities. One is transmitter or sender, and the second one is receiver. So at the transmitter side or sender side, the signal data is modulated and sent using the LED bulb in the form of zeros and ones. So how are the zeros and ones distinguished by the help of flashes from the LED bulb, that is the light flickering. Okay, right, and at the receiver side there will be a photodiode which will receive the light signals, and the amplifier will be amplifying these received LED flashes. Okay, which will strengthen the signal, and the output will be sent to the receiving device. So this is the basic process how the Wi-Fi system works. So Wi-Fi uses visible light communications, or you can say visible light spectrum. Okay, Wi-Fi uses electromagnetic spectrum, whereas Wi-Fi uses visible light spectrum. The light spectrum is like 10,000 times greater than the electromagnetic spectrum. Okay, and the speed is very high. So Li-Fi uses LEDs, as I already told you, and the data transfer rates can increase up to 224 gigabits per second. Okay, this is humongous increase in the speed when compared to Wi-Fi. Wi-Fi supports up to 2 Gbps. Okay, generally. But if you see here, this is like 100 times more than Wi-Fi speed, right? So if you have Wi-Fi and if you have this speed, you can basically download 250 GB of data per second. Yes, right. And this technology operates via illumination, that is through LED flashes, and the essential devices that are required are light emitting diodes, that is LEDs, and on the receiving side we need photodetectors or photodiodes. So these are some differences between Wi-Fi and Li-Fi. So full form light fidelity and Wi-Fi is called wireless fidelity. Operation, so Li-Fi uses LED bulbs for flashing the light, and Wi-Fi uses routers and it works through radio waves. And coming to interference, in Li-Fi we have less to no interference. Okay, whereas in Wi-Fi we might encounter interference due to nearby access points, Wi-Fi access points. And technology, in Wi-Fi we have IoT compliant devices. In Wi-Fi we have 802.11 A, B, G, N, AC or AH compliant devices. And applications, Wi-Fi can be used in airlines, it can be used in underwater. Light is uh, not blocked underwater, whereas the radio waves, that is Wi-Fi, are blocked under water. So Wi-Fi cannot be used. We can use Wi-Fi. We can use it in hospitals and many more areas. Whereas Wi-Fi is generally used for internet browsing. Advantages of Wi-Fi, as already told, less interference. It passes through water and works in dense regions. Okay. And advantage of Wi-Fi is, since it is being already used, there are so many Wi-Fi devices already available. The available infrastructure is more when compared to Wi-Fi. Some more differences: privacy or security. So light is completely blocked through walls, so we can have secure data transfer within the region. But if you come to Wi-Fi, the radio waves leak through the walls. Okay, so security is less in that sense. And data speed, just now we have seen 224 Gbps, whereas Wi-Fi is only 2 Gbps. Frequency, as I already told you, visible light spectrum is 10,000 times greater than the electromagnetic spectrum, whereas Wi-Fi uses these frequencies, that is in the electromagnetic spectrum. And data density works in high density environments, Wi-Fi, and Wi-Fi works in less density environments because of interference issues. Okay, and the range of Wi-Fi, this might be a disadvantage. Its range is very less, 10 meters, when compared to Wi-Fi, whose range is 32 meters. And in a Wi-Fi system, we need the lamp driver, LED, and photodetector. Okay, in Wi-Fi, the typical devices are routers and the end devices. So those are the differences between Wi-Fi and Li-Fi. So advantages of Li-Fi: it offers high speed, 224 Gbps approximately. It provides security because the light signals are blocked by the walls. Since we are using visible light spectrum, it is completely harmless for human beings, and the speed of data is consistent. Okay, because of less interference. So it has some disadvantages. So line of sight problems. Okay, that means if someone, let's say a human being or a thing or a non-living thing comes in between the LED bulb and the receiver, the light is blocked. Okay, so then we will have the line of sight problems. So such things creates interference in the data transfer, and dim areas in the room is are also a disadvantage for data transfer, right? If light is not reachable in a particular area in the room, data transfer cannot be carried out. Okay, as we have seen, Li-Fi offers only 10 meters range, so in respect to that, we have some range issues. Okay, right. Uh, that's it about Li-Fi. Now we are going to look at LPWAN. So LPWAN abbreviates to low power wide area networks. Okay, so WAN means wide area network, and LP means low power. Okay, so this is not a protocol, it's a term or concept. So it's an umbrella term which contains different wireless technologies which have the following characteristics. So the characteristics are, uh, they support large coverage areas. So we will see the wireless technologies in the next slide. So all those technologies cover large distances and low bandwidth, that is the speed is somewhat less, and they transfer very small packets, that is the data in the form of small packets. Because of that, these LPWAN technologies offer long battery life because they are transmitting only small packets. Okay, so all these wireless technologies which falls under low power wide area networks are specifically designed for IoT use cases. Okay, so these are some of the technologies, wireless technologies, which falls under LPWAN. So first thing is LoRaWAN, another one is Sigfox, another one is narrowband IoT, NB-IoT, another one is long-term evolution M, LTEM, and another one is YSUN. Okay, so I have mentioned only some of the important or famous technologies. There are others also, we will see in the coming slides. So I am not going to explain about each one of these protocols. If you are interested, please search on the internet with these names. You will get a lot of information. So some important points. So just now we have seen all the technology, wireless technologies, right? Like LoRaWAN, Sigfox, NB-IoT, and all these things. They have similar architectures. That is, you will have same type of components, but the terminology is different. Okay, the names with which you call the specific devices, the terminology is different. We will see in the next slide what is the terminology, and general type of entities which are available in a LPWAN network. Either you consider LoRaWAN, you consider Sigfox, you consider NB-IoT, or whatever. You will find all these general entities. So first one is end devices, the mobile phones, laptop, desktops, or whatever end devices. Sensors can be also considered as end devices, actuators, and all these things. Uh, and then the sensors, if you consider sensors, they will have radio gateways, okay, to send the data. And then we will have router which will send the local data to internet. Okay, and then we can have LPWAN AAA server. This is particularly used for providing security. And then we will have the application server where the application will be stored and is used to serve the users. So here you can see the terminology which is followed by these different wireless technologies. So on the left hand side we have the devices. Okay, so these are end devices. This is the radio gateway, and this is the network gateway, that AAA server, and last one is application server. Okay, so pause the video here for a few minutes and see the terminology. Okay, right. So this is the general architecture of any LPWAN technology. Either you consider LoRaWAN, either you consider Sigfox or whatever. The general architecture is this. So here we have end devices. Okay, these devices will be gathering data, or will be receiving data, and the data will be sent through the radio gateways to network gateways, and finally the data is sent to application servers where the data can be stored in the database. The data can be analyzed and some decisions can be made. Okay, right. So as I told you previously, not only LoRaWAN, Sigfox, MBIoT, LTEM, and YSM, there are so many other technologies. So you can see them here. So here there are two main categories: LPWAN technologies, and another category is adjacent or comparative technologies. So what is the first category is this: whatever technologies you are seeing under LPWAN technologies, these are standard technologies. Okay, they are already recognized by the industry. Whereas if you see this second category, that is adjacent or comparative technologies, they are very similar to LPWAN technologies, but they are not standard technologies. Okay, they are not recognized, but they are very similar to LPWAN technologies. Okay, and one more category of different differentiation you can see here is licensed spectrum and unlicensed spectrum. Okay, so licensed spectrum, these are generally cellular technologies. Okay, and these unlicensed spectrum, these are generally non-cellular technologies. Okay, as well as these things also unlicensed spectrum. Okay, right. And the comparison between some of the LPWAN technologies. So you can see here LoRa, Sigfox, NB-IoT, LTE, GNU, Weightless, and Link Labs. So on the left hand side, you can see the features based on which they are differentiated. So I request you to pause the video and see all these things. And we have some more differences. Okay. So pause for a minute and go through these things. So that's it about LPWAN. Okay. So with this we end our unit 2. So I have covered all these things until now. So first we have explored IoT components, and then we have discussed about IoT architecture. We have seen some examples of IoT architecture, and after that I discussed about IoT design methodology by using this home automation system. There are 10 steps in the design methodology, and each step has been explained with the help of home automation system. And after that we have entered into wireless protocols. So I have started this with RFID, then Bluetooth low energy, IEEE 802.15.4, also called as LR, WPAN, low rate wireless personal area networks, and then I have discussed about Wi-Fi, wireless fidelity, and then I have discussed about 6LoWPAN. So 6LoWPAN means IP version 6 over low rate wireless personal area networks, and then I have discussed about Zigbee. After that, fourth generation and fifth generation technologies, and in the today's session, I have talked about Li-Fi, and I have finally discussed about LPWAN. So with this, we have completed unit 2. Okay, thank you.